Hello my dear students. Okay, more solute can be dissolved in it. Now we are learning about the gas in a liquid. So gas is the solute and the liquid is the solvent here. As the mole fraction is going on increasing, the partial pressure is also going on increasing. What happens is, cold water temperature is less. So more amount of oxygen can dissolve in water. They are carrying the cylinders which is diluted with helium. As we go higher from the sea level, as we move up in the altitude, the pressure goes on reducing. Hello my dear students, welcome back to the second session on the chapter Solutions. Last class we had learnt about types of solutions, also expressing the concentration of solution in terms of molarity, molality, mole fraction, etc. Today we shall learn about solubility of gases in liquids or solid in liquids. So the first one, what is solubility? Solubility of a substance is its maximum amount that can be dissolved in specified amount of solvent. It depends upon nature of solute and solvent as well as temperature and pressure. That is, if a particular solute is taken, what is the amount of solute which can be dissolved in a particular solvent. So the amount of solute what you are taking, okay, how much can it be dissolved in a particular solvent, that is called as solubility of that particular substance. Now what are the factors which affect the solubility? Nature of solute, nature of the solvent, temperature and pressure. All these four things are going to affect a solubility of a particular substance. We learn in particular about solubility of solid in liquids. Okay, we are going to study about the solubility of a solid in liquid. That means solid is the solute and liquid is the solvent. Okay. Now here it is observed that polar solute dissolve in polar solvent, non-polar solute dissolve in non-polar solvent. For example, if we take sodium chloride, NaCl, it's a polar molecule, it's an ionic molecule, correct? So it has got polarity, Na plus Cl minus. So if I take sodium chloride, it will easily dissolve in water which is a polar solvent, correct? Whereas if I take sodium chloride and try to dissolve in benzene, it will not be soluble. You cannot dissolve there because benzene is non-polar solvent. So what is it? Polar solutes will dissolve in polar solvent, whereas non-polar solute will dissolve in non-polar solvent. For example, for non-polar I can give naphthalene. Naphthalene if I take and try dissolve in benzene, it will dissolve. But if I take that naphthalene and try to dissolve in water, it will not dissolve because naphthalene is a non-polar solute. It will dissolve in which? Non-polar solvent only. So we can tell that like dissolves like. Okay, that means the solute dissolves in a solvent where intermolecular attractions are similar. So in the solute as well as the solvent, they should have similar intermolecular interaction. So if they have similar intermolecular interaction, then it will be soluble. Okay, example you can take sodium chloride and sugar dissolves readily in water because they are polar solutes, whereas naphthalene and anthracene dissolves readily in benzene because they are non-polar. Okay, so that is about solubility of a solid in a liquid. Going further, next we are going to study about the concept dissolution and crystallization. What do you mean by dissolution? Dissolution means some amount of solute dissolves in the solvent and the concentration increases in the solution. This process of dissolving a solute in a solvent is called as dissolution. Okay, so if I have taken some sugar, added to water, as this sugar particle dissolves, the concentration of sugar increases in this solvent and you get sugar solution. The process of dissolving a solute in a solvent is called as dissolution. So solute in solid state will go into the liquid state. Okay. Now what do you mean by crystallization? Some solute particles in solution collide with the solid solute particles and get separated out, and this is called as crystallization. Now in the solution what happens is, more and more if I go on adding the solute particles, at one point the particles will start colliding with one another and they will start forming crystals again. So that process is called as crystallization. Okay, to understand better, we'll see here. See here, first initially what happens, you've added the solute particles are going into the solution. The solute particles are going into the solution or they are dissolving. That process is called as dissolution. At here also you can see some of the solute particles are still going into the solution. Now the solute particles in the solution are going on increasing and some of them are coming back to form the crystal. At one point of time where the number of particles which is dissolving will be equal to the number of particles which is getting crystallized. Okay, and that stage is called as equilibrium state. Okay, a stage is reached when both the process occur at the same rate. Under such conditions, number of solute particles going into the solution will be equal to the solute particles separating out, and this state of dynamic equilibrium is reached. So what happens here is, the solute which is in the solid state, okay, first will start dissolving. So this is dissolution process. Okay, so solute in liquid state. Okay, now the solute in the liquid state, at one point of time they collide with one another when the concentration is going on increasing, and from the liquid state it will start coming to the solid state. That process is called as crystallization. Okay, when these two processes are happening in equal rate, that time we call that state as equilibrium state. Okay, so I hope you have understood about dissolution as well as crystallization. Next we learn about saturated solution and unsaturated solution. So what is saturated solution? No more solute can be dissolved at same temperature and pressure in a particular solution. Such solutions we call it as saturated solution. What do you mean by unsaturated? More solute can be dissolved at same temperature in a particular solution. We call it as unsaturated. To understand better, we have, see, I have a particular solvent, I am adding the solute. More and more solute as you are adding, it is still dissolving. Such solutions are what? Unsaturated solution. Okay, more solute can be dissolved in it. Now what do you mean by saturated solution? At one point of time, as I am adding the solute, no more solute will dissolve. Okay, you cannot dissolve more solute at that particular temperature and pressure. That is called as saturated solution. Okay. Now for example, if we are preparing jamun at home, gulab jamun, you all might have eaten gulab jamun or you might like it. Okay. So here when they are preparing that sugar syrup, you see, first they'll take water and then they'll add some amount of sugar, it will dissolve. Okay. At a particular point of time, the sugar will stop dissolving. If you start heating the same solution and then you start adding more and more sugar, it will still continuously dissolve, okay, up to a certain extent. That means as the temperature is rising, that particular solution could take some more amount of sugar in it, okay. Only then we get the thick syrup which is required for our sweet. Correct? So there, first the solution what is there becomes saturated at one temperature, at room temperature. After that, when the same solution, if you heat it and then add solute to it, it will still dissolve. It is capable of taking some more amount of solute. Okay? That is why we always tell in the definition, it is saturated at a particular temperature and pressure. Okay? It is saturated only at that temperature and pressure. If there is a change in temperature and pressure, maybe that solution can take up some more amount of solute. Correct? Have you all seen all of this? I hope you have entered the kitchen and seen all of this. Okay. Anyways, what do you mean by supersaturated solution? Now, if a solution has taken up a lot of solute into it, okay, at one particular temperature and pressure, it has taken more than what was supposed to be its solubility. It is super saturated, we call it as. That is, if I change the temperature, it will take some more amount of solute and it becomes a super saturated solution. Now for that, if I add a tiny small amount of the crystal, okay, then that crystal will start taking up all these extra solute particles whichever was there in that solution, and the crystal starts to grow. So always that adding of that tiny solute particle, we call it as seeding. In a supersaturated solution, if you seed it a little with a crystal which was dissolved as a solute there in that solution, then that crystal will start growing in size, okay, in supersaturated solution. I hope you have understood this. Anyways, the supersaturated solution concept is not there for you all for your second PUC, but of course you will require it for your competitive exams here and there. Okay. Next we will be learning about effect of temperature and pressure on solubility of a solid in liquid. Okay. So here what happens? Solubility of a solid in liquid is affected by temperature change. I already told you all and gave you all an example also. So according to Le-Chatelier's principle, the dissolution process is endothermic. If dissolution process is endothermic, what do you mean by endothermic? It requires heat for the dissolution to happen. It absorbs energy. Okay, it's an endothermic process. Then the solubility should increase with the rise in temperature. That means if you are increasing the temperature, you are giving heat or you are giving energy for that. So more energy it will absorb and the dissolution process will increase. So if it is endothermic, then the solubility will increase with the increase in temperature. But if dissolving, okay, or dissolution process is exothermic, that means the heat is liberated, okay, then the solubility should decrease with the increase in temperature. It is already liberating heat and you are trying to heat it more, then of course the solubility of the solute is going to reduce with the increase in temperature. So this is the effect of temperature on solubility of a solid in a liquid. What about the pressure? Pressure does not have any significant effect on the solubility of a solid in a liquid. Because it is a solid, pressure does not affect in the solubility. Okay. So that is about the effect of pressure as well as temperature on solubility of a solid in a liquid. Next we learn about solubility of gases in liquids. Till now what did we speak? About solid in a liquid. Now we are learning about the gas in a liquid. So gas is the solute and the liquid is the solvent here. Now what about it? See, solubility of a gas in a liquid is affected by pressure as well as temperature. So again, pressure as well as the temperature affects the solubility of a gas in a liquid. Again, nature of the gas as well as the solvent also affects the solubility of a gas in a liquid, which we are not studying it in much detail. So we will be learning more about the effect of pressure and temperature. Okay, so here we have something called as Henry's law. Okay, what does this law tell? The law states that at constant temperature, the solubility of a gas in a liquid is directly proportional to the pressure of the gas. In this example here, I have taken a solvent and there is a particular gas which is present. Now here if you observe, at a particular pressure, there are some gas particles which have already dissolved in the liquid. Can you see here? It is dissolved in the liquid. Okay. Now, and there are some gas particles which is there just randomly present in that space above the liquid. Correct? Now, as the pressure is increased, you can see I have increased the pressure. Pressure is increased. You can see more and more gas particles will start coming into the solution. So, what does Henry's law tell? It tells us that solubility of a gas in a liquid is directly proportional to the pressure of the gas. So if I go on increasing the pressure of the gas, the solubility of that gas in a liquid also goes on increasing. So they're directly proportional. I increase the pressure of the gas, then the solubility of that particular gas in the solution also goes on increasing. This is what Henry's law states. Now further, here you see the solubility of a gas in a liquid solution is a function of partial pressure of the gas. What do you mean by partial pressure? The pressure exerted by that particular gas, we call it as a partial pressure. So what they are telling is solubility of a gas is a function of partial pressure of that particular gas. So the pressure of the gas is directly proportional to its solubility. Okay, that is, if the pressure is increasing, the solubility also will increase. Or Henry's law can also be stated like this. It is that the partial pressure of the gas in the vapor phase, okay, is proportional to the mole fraction of the gas in the solution. That is, if I have, this is my solution and I have gas particles here. I have some gas particles which are just not dissolved yet. Okay. Now, if what Henry's law tells us that the partial pressure, this is the partial pressure of the gas, okay, in vapor phase, which is taken as P. It is directly proportional to mole fraction of the gas in the solution. Okay, so how much gas is present in the solution? Its mole fraction is proportional to the partial pressure of the gas above it, in that it's in the vapor phase. Okay, we can write it as P is proportional to X, that is, as the partial pressure of the gas is increasing, the mole fraction of the gas in the solution also will increase. They are directly proportional. To remove the proportionality constant, KH is added. So what is KH? It's called as Henry's law constant. X is mole fraction of the gas in the solution. P is partial pressure of the gas. So I hope you understood what is Henry's law. It is a very, very, very important question for your exam. They have asked several times here. 1 mark also they can ask. State Henry's law. You're supposed to write the statement. With the mathematical form, they can ask for 2 marks. So you need to write the statement of Henry's law and then you have to write the mathematical form as well. So we'll see with the graph now. Here, if we draw a graph between partial pressure of the gas versus mole fraction of the gas in solution, it should be like this. So we have taken the partial pressure of HCl and we are taking the mole fraction of HCl. Then we should get a straight line. That means as the mole fraction is going on increasing, the partial pressure is also going on increasing. It means to tell that they are directly proportional to one another. Okay. Higher the value of KH at a given pressure, the lower is the solubility of a gas. This is the relation between the Henry's law constant. Okay, what is it? If the KH value is higher, that means to tell us that the solubility of the gas in a liquid is lesser, it is lower. Okay, so that is about Henry's law. Next, we learn about effect of temperature and pressure, okay, on solubility of a gas in a liquid. Now here what they are doing is, I have shown here pressure P1, I have my gas particles which is there in the vapor phase, I have some of the gas particles which is dissolved, which is in the solution phase. Now here if I increase the temperature, okay, if I increase the temperature, solubility of a gas in a liquid decreases. Solubility decreases. Why? Because as you are heating it up, the gas tends to escape. It will start escaping from the solution phase. Okay, so that is about increase in temperature. Now if we increase the pressure, okay, and temperature is also reduced, temperature is reduced, pressure is increased, that will increase the solubility. So solubility increases if pressure is increased and temperature is decreased. Okay, so that is about the effect of temperature and pressure. Again, such questions can be asked for 1 mark also. What is the effect of temperature on the solubility of a gas in a liquid? So if the temperature increases, solubility decreases. If the temperature is decreased, solubility can increase with also the increase in pressure. Okay, so I hope you have understood about the concept. Next we are going to learn about applications of Henry's law. So what are the applications of Henry's law? Solubility of a gas increases with the decrease in temperature, correct? This is the reason aquatic species are more comfortable in cold water than in warm water. What happens is, cold water temperature is less, so more amount of oxygen can dissolve in water, correct? Because of which the aquatic animals will get enough oxygen there. Hence aquatic animals are very comfortable in cold water than in warm water. If the water becomes warm, then the gases which is dissolved start escaping and it will not be enough for the aquatic species. So that is the first application which we can see around us. Second is, to increase the solubility of carbon dioxide in soft drinks and soda water, bottle is sealed under high pressure. I told you, as the pressure increases, the solubility of a gas also will increase. They are directly proportional. So if in all the soft drinks, okay, many soft drinks are there which we see around us, or any soda which is there, we have carbon dioxide gas which is responsible for that frizz which comes out as we open. So at a very high pressure, the carbon dioxide gas will start dissolving in the particular liquid, and it is sealed under that pressure so that it remains in that state. As we open out, the pressure decreases, because of which the carbon dioxide comes out and you can see it in the form of a frizz which is coming out. Okay, so that is the second application which you can see. Next application is about bends. What is this bends? That is, see, scuba divers, you have seen they take a cylinder a gas cylinder along with them, and they dive deep into the sea. As we go below the sea level, the pressure is going on increasing. So as the pressure is increasing, the gases which we breathe, okay, they will start dissolving more and more in the blood inside our body. So at a very high pressure below water, the gases are dissolved. Now suddenly if they come up to the sea level, the pressure decreases and the dissolved gases will come out in the form of bubbles. They will form small bubbles in the blood. And because of the formation of these bubbles, there is a disease which can cause, which is called as bends. Okay. These gases which comes out, or the release of the dissolved gases, leads to the formation of bubbles of nitrogen, especially nitrogen in the blood. This blocks the capillaries and creates a medical condition known as bends. Okay, and which is very painful and dangerous to life. It is also called as decompression sickness. What is it? Decompression sickness. This condition is really dangerous. As they go below, all the gases dissolve in the blood, but when they come up suddenly, these bubbles formed can be very dangerous and very painful when they block the capillaries or any of the veins. Okay, so that's about the condition bends. It's a very important question again. Also, to avoid bends, the toxic effect of high concentration of nitrogen in blood, they carry tanks with air. These scuba divers have filled air which is diluted with helium. Okay, it is diluted with helium. It has 11.7% helium, 56.2% nitrogen and 32.1% oxygen. So they are carrying the cylinders which is diluted with helium and has got less amount of nitrogen comparatively. Okay, so that is about the disease bends. There is one more application, that is in mountain climbers. Okay, what happens at a high altitude? The partial pressure of oxygen is less than that of the ground level. As we go higher from the sea level, as we move up in the altitude, the pressure goes on reducing and the pressure of oxygen is very less than that of the ground level. This leads to low concentration of oxygen in blood and tissues of people living at high altitude or climbers. Anywhere, if they are living at a very high altitude also, the oxygen which is there, which all the tissues can get, will go on reducing because the pressure around there is very, very less, due to which the gases will not be dissolved properly in the blood, causing the deficiency or the low concentration of oxygen in blood. Low blood oxygen causes climbers to become weak and unable to think clearly, and this is the symptoms of the condition called as anoxia. Okay, what is it? Anoxia. So anoxia, oxygen is reduced or it is in less quantity. So that is about the last application of Henry's law. In the next class, we will be learning about Raoult's law and we will solve some of the numericals. I hope you have understood today's class. Thank you, my dear children. Stay tuned, stay focused.